continue.
Yes, yes.
We will continue from where I have stopped.
Okay, we will start now.
Right. So I'm just sharing the screen here.
Screen, no?
So I think it is visible now. Screen.
Yes.
So in the morning, what we have discussed creation of standardized data. So what we call is ISID score, right? So ISID score generally, it can be used if it is unidirectional data. It can be used for creating composite exons. Now, unidirectional means if all are in the same direction. For example, if the sex ratio is a positive, literacy should also be positive variable, as well as the percentage of other work should also be a positive variable. Means it in the same direction. If at all you are including negative variable, say for example, if you are including infant mortality rate into this development index creation, then you have to convert that into positive by taking the reciprocal before you standardize the variable, right? Right. Now we will move on. Now, just if anybody is having some doubt on the Z score, how these Z scores are created. Again, I'm telling these values I have subtracted from the mean of this value and then divided it by the standard deviation. Manually also you can generate this. Now this I did using descriptive, and I just clicked on this, right? So I'll just see what I did is I clicked on the save standardized value as variables. Okay, so again it will create. Okay, so it has created the same thing again, right? Now with that, if you see, you got a table also, because when we clicked on this descriptive, when we selected it, it is expected that that the basic statistics, which is tick, also will be generated. Okay, so you can see that sex ratio. Now the number is 640, which means that we have around 640 districts, out of which the minimum sex ratio was found to be 533, and the maximum is 1184, and the mean sex ratio in India is 945.47, and standard deviation is 60. Similarly, literacy. So the basic statistics you get from this descriptive analysis. Now, if you want more, you can select from variance, range, the distribution, the skewness and kurtosis of the distribution. You will get from this. Okay. So now how this is generated is manually. Let us say Z of SR is equal to sex ratio minus its mean. Now, what is the mean of that? The mean of the sex ratio is 945. So I take that value and put it here, and then it is divided the standard deviation of that. So basically it gives how much standard deviation, the mean is away from the individual value. So if you do this, exactly you will get the same Z score as it is automatically generated. So look at this, it is the same thing as this one. So both of these are same. Okay. Only thing is this is 2 decimal places. So if you increase the decimal places, it will, you will get the same figure, right? All right. So moving on, how we can create a frequency list. Now the next aim is, you know, once you create the indicators, my objective is to know how many you know, districts in India are falling in certain category. So for that I need to create you know, categories. So for example, sex ratio. I want to identify the number of districts in India where sex ratio is less than 800, or the sex ratio is between 800 to 900, or it is between 900 to 1000, or greater than 1000. So I want to, if I want to create, let us say 4 categories. So what I do is I use recode. So there are, in recode, there are 2 options: recode into same variable, recode into different variable. So recode into same variable, we should use only if we don't want the original variables. Our intention is to create an additional categorical variable by keeping the original variable. Then always you should make it as a practice that using recode into different variable. Don't use recode into same variable. Then what happens? The original variable will be lost. Okay. So use recode into different variable for converting a ratio variable into a categorical variable. Okay. Now, sex ratio. So I selected sex ratio. Now you have to give a new output variable, because using this variable you are creating a categorical variable. So I use categorical variable sex ratio, right? SR or sex ratio, whatever you can type. And you click on change. Right now you can see a question mark here. So you click on change. So there is the sex ratio will be transformed to categorical sex ratio. Now, how it will transform? You have to define the old and new values. Okay. What are the old values? Old values are the category. You specify that. Now, category can be specified in these 3 options. Basically, ratio scale, these are the 3 options: range, range lowest through value, or range value through highest. Now, the first ones and the last one being open categories, less than 800 or greater than 1000, we have to use either of these. Okay. And for less than, you have to use this one. For more than, you have to use this one. And if it's a closed interval, then use range. So let us begin by giving less than 800 as code 1. Now, all values less than 800 sex ratio will be coded as 1. So this is recoding the variable, right? Now, then the next one is a closed interval where you put 800 to 900 and code it as 2. And then 900 to 1000, you code it as 3. And range value through highest means 1000 and above, you know, it will be coded as 4. Okay? Now, once this is done, you need to say continue and click OK. Okay. So you can see that at the end of this, a sex ratio, categorized sex ratio is created. So because those are categories, you don't need the decimal places, you can remove it. Okay. So wherever the one is found, which means that the value is less than 800, etc. Now, what you can do with this data is you can create a frequency distribution. How? Go to frequencies and then select. Now see the difference. In all these, you can see a scale which indicates that the SPSS has saved it as a ratio scale variable. Whereas here you can see 3 circles, which means that it recognizes it as a categorical variable, right? And if it is a string variable, it will have this 2 circles and 1 A. A stands for alpha, right? Which means that it is a string variable, right? So if I want, the frequencies of this categorical sex ratio, you select this variable and you click OK. Okay. So you get the frequencies. There are 7 districts where you have ones. What is ones? There are 7 districts in India where sex ratio is less than 800. 131 districts falling in between 800 to 900 sex ratio, and 405 districts between 900 to 1000, and then we have 97 districts where the female population is higher than the male population. So in India, female population is higher, or female dominated districts are 97 out of 640, and it makes 15.2% of the total number of districts. Now here you can see the percentage and valid percent are same because there is no missing value. Okay, if there is a missing value, then the valid person, that missing observation will be removed. Only valid observation will be used for calculation of the valid person. Since there is no missing value, the both are same. And the last one is the cumulative frequency or the cumulative percentage distribution. So what is, what you have seen here, although it has generated the frequency distribution, it has not given the value code. See, here you can give a value label. Now, what is 1, 2, 3, and 4? Suppose you exchange this table with somebody else, they do not know 1, 2, 3, 4, what exactly it means. So you need to give the right labels for this. For that, you need to create value labels. So how you create value labels? You go to, there's an option in label. Here you can put a label also. That is sex ratio categorize, or sex ratio, okay, categorize sex ratio, something you can write. This is a variable label, but the value label you have to specify here. You click here, then you will get this screen where you can write 1 means less than 800. 2 means 800 to 900. 3 is 900 to 1000, and 4 is greater than 1000. Okay, so that label has come here. See, you just click and you'll get back that. Okay, now if you do the same frequency distribution, what you are getting is like this. So the label, so the number, these codes are replaced by its label. Okay, so this will be a better. Now even say cat SR is replaced by categorized sex ratio. So putting label, proper label, variable label as well as value label is important in visualizing your or getting your table in a proper manner, right? So Now let us create one more categorical variable. Then we can do some kind of cross tabulation, as well as we can generate customized tables also. Right. Now let us create another categorical variable by making a category of literacy percent less than 60%, 60 to 70%, 70 to 80%, 80 to 90%. Let us say greater than 80%. So 4 categories, again 4 categories. Okay. So that how we do, again recording to different variable. Now already that formula is there. What you do is reset. So it is removed. So come to the literacy rate, and then you can say categorize literacy. Click on change, and then range lowest to 60 is 1, then 60 to 70 value as 2, 70 to 80 as 3, and then 80 plus is 4. Now click continue, and then okay. And even here now you can, now for if you don't want to type like this, you can write the syntax also for that. You can create the, how you create a syntax, file, new syntax. So in the syntax you can say that what is the variable name, that is cat lit. Okay. So you can write value labels. So there's an option called value labels. Say cat underscore lit. Now here 1 is less than 60, or 2 is to 70. See, I am putting that within double inverted column. So 3, 70 to 80, and then 4 is greater than 80. Okay. And after that, what I do, I put a full stop. As I said, that this is the symbol for the command terminator in SPSS. So you, after that, you just run it, and you will get that thing here. Okay. So look at this. So this has come here. So manually, if you want, you can type here, or you can using this syntax, using the value label syntax, you can write it over here and run it. So now what you got, this is categorized. So you can see the, sorry, this one, frequency, right? You can reset it and see the literacy rate. The districts, out of the 640 districts, 78 districts still has a literacy level less than 60%. And 60 to 70, around 182 districts, and 70 to 80, 222 districts, and about 158 districts in India out of 640. That is 24.7% districts have more than 80% literacy. So this is how you create. Okay, now this table you can copy and paste it in your Microsoft Excel. or Word or wherever you want. Okay, so it is compared to Stata, it gives better formatted table. Okay, now if you want to do a cross table between these two, okay, what you do is descriptive statistics cross tab. What does cross tab gives? It's a two-way contingency table that by taking sex ratio, categorize sex ratio in rows and literacy rate, the category of literacy rate in columns. Then what you have to do is use one here and this variable here. Okay, and you see, you click OK. What you are getting is now all these numbers are the number of districts. Okay, now what is less than 1 means? 1 means there is one district where it meets both these criteria. Means one district in India where sex ratio is less than 800 as well as the literacy rate is less than 60%. Okay, so the intersection, you just see how you so 46 districts are there where the female population is higher as well as the literacy rate is also 80%. Okay, so it gives you a kind of good correlation. Now here the purpose of this is not to find out any because if you have a continuous data, or if you have a ratio scale data, then you don't require this for finding out the relation between sex ratio and literacy. You can straight away do a correlation. Okay, but this is basically used for generating this kind of tables. And what else? Suppose if you want a row wise percentage or column wise percentage or a percentage of the grand total, all this is possible in this. Okay, so if you go to the cross tab, the cells, if you go to the cell and there are options like percentage, row percent, okay, or column percent. Okay, if you put all these, then it will be a confusing table. So if you just look at it this one by one. So what is row percentage? So see, that means this out within the less than 800 cat, what is the percentage of this literacy level? So 14% in this category, 57% in this category, and 28.6% in this category, and this add up to 100. So the row wise it add up to 100%. Okay, so now you can easily understand, right? Now similarly, the percentages within each of the category, then you have to take column percent. Okay, percentage of sex ratio within each of these categories, then you have to take the column percent. How you get that? It's just simple. They click on the column, so you get this one. So now the percentage is calculated out of each column. Okay, so that the column add up to the 100. Okay, in case you need only the percentage, you don't need the actual frequencies. So that option also is there in SPS. So all these are simple because with a click you can get it. So I don't want this observed frequency. Okay, I want only the percentage, column percent. So that is there. Okay, so it gives only the percentages. Okay, so it just remove this. Otherwise, all these values 16.7, 16 points, all these percentages are appearing here. Now, apart from that, in the cross tabulation, it gives you the not this one. You can go to the statistics if you want a chi-square. Now here also, suppose your data, you don't have the actual data, you have only this categorical data, or you got the categorical data only, but still you want to see the associationship between these two categorical variables, you can do a chi-square test of association. Okay, so it gives you, a Pearson chi-square value. It's 38.32. Now, what is the, see, whenever you do a kind of test, then there, the concept of null hypothesis, alternate hypothesis come into picture, right? So here, what is the null hypothesis? That there is no association between, the literacy and sex ratio. Okay, and the chi-square value with a highly significant, it's 0.000 is the probability value, the significance value. So which means that it's highly significant. That means 99.99% confidence in the relation between associated with. That means you are, when this becomes 2.0520, which means that statistically we say that this is significant, which means that we reject the null hypothesis. Okay, so when it is 0.05 or above, if it is less than that, we reject the null hypothesis. That now we can say that there is an association between literacy rate and sex ratio. Okay, so not just looking at the value, looking at this level. Okay. Now, another thing we can do with is, this is a very, custom tables. Okay, you can create tables, custom table. Okay. Now, let me just see what are the best variable for doing a custom. Okay, so let us now, for creating a custom table, you need categorical variable as well as the ratio scale variable. Okay, so you can, in whichever way you want to create the customized table, you can create it. That's very important, very good tool to create the tables, according to your layout. Okay, so that is custom table is very important. When I say according to your layout, the whichever way you give, whether column, row, or how you want to fit it, you can do it. Now let us create one. Now suppose my aim is to, now something you should remember. Okay, what is that? I'll tell you. Now suppose I want to generate. Now my aim, what is my aim? My aim is to find out, let us say, what is the average percentage of workforce in secondary and tertiary? See, I said we have created percentage of other workers, so which reflects mostly the secondary and tertiary workers. So what is the average secondary and tertiary workers falling in this sex ratio and literacy category? Okay, so if that is your aim, what you should do is you take this and bring it here, right? Now what we did, categorize sex ratio, I brought and dropped here. Okay, now, and this one, literacy, I have dropped here. Okay, so it looked like a two-way table as we did it in the cross tabulation. Yes, you will get the same table if now you click OK. Right? So my see, if you do a, you can category total also, that it will give you the total of this, and similarly here you can do a category total, so that you get the sum here as well. Okay, now if you just click OK, so you get this is the same table as that of the table which we have created here. This table and this table are same table. Okay, now our aim is not that. Our aim is to create what is the summary tables. What is the average percentage of other workers in these distributions? Okay, so what I do is I take this variable. Now, make sure when you do any kind of summary statistic, make sure that it is a ratio scale variable. Otherwise, it will not do. Okay. See, for these one, it should be, because these are categories, but this one for which I'm going to average. So it has to be a scale variable. Okay. So you just bring it and keep it here. Okay. Now you see, you got a different table. So what does it mean? Can you tell what is how will you read this table? What is this 73.31? Can anybody tell? Now 73.31 means this is the average percentage of secondary and tertiary workers if the literacy is less than 600 and the sex ratio is less than 800. In those districts, the average percentage of other workers is 73.31. So here it is the count, but here it is the average. Okay. Not only this. Now this seems to be okay, simple, right? But I want more. I in fact want something else, because this is an all India table, but I want this state-wise. For each state, I want this table. By the way, when I say that I'm just giving you the tools, I'm introducing the tools, you can think about your own, for apply all these for your database. Okay, just giving idea how you can, use these tools. Right? Now, suppose I want this, state-wise. I go to the custom table. Now I bring in state also here. See what I did? State, and then you click OK. See, now some are blank, which means that there is no such exist. Means there is no such districts where less than 600 in Andaman and Nicobar Islands. Okay, there is one. There may be more than in 70 to 80 as well as less than 800. The average is, and this can be a single district or more than this. So this gives you the average. Okay, so each states, though this table looks complex, but when you have other data, let us say that large. This is only 640. So in some of the cells, you may get missing value. If you have large data sets, then the state-wise you can do generate many kind of tables. Right? So you understood this? Is there any doubt in this? I hope. Now, if you don't want this again, you can bring it here. Okay. Remember, if this is like this, variable is something like the state variables, assume that it is a ratio kind of thing, then it will not work. So have to make either as a string variable, or it should be a categorical variable to see it in categories. Right? Now, sometimes you may see, here, let us see, where is that? Okay, this one, the format also, that is also important. Okay, see, sometimes, wait, this one, cancel it. So the format here, it was 2 decimal places. Okay, if I don't want, I want only 1 decimal places in the result, what I do is you can go to that table again and then click here, get into the summary statistics and remove this auto and make it n.nn, and then decimal, you make it 1. So it becomes apply to the selection and you click OK. So it becomes now, because I selected that comma, but if you put that point option, then you will get point. Okay. So I think I have you. Yeah, this one. Okay. Apply. Okay. So it comes in 1 decimal place, right? Now that is about the customized tables, right? Then how you can perform. Now the next thing is how you can do an aggregates of this. You know, so in Microsoft Excel, what happens, you know, whenever you get this kind of data, now you have let's say I want to create a state. This is district level data, because for each district, I want to create a state level data set out of that. One is that, you know, you can generate state level, you know, table by using a custom table, and then you click, just reset it, all tabs, you say state, bring it here, and then you can select all. Suppose I want to create a, you know, now state level, suppose some of the data. So what you do is you select some and then put it here. Okay, you could have selected all and then you could have done the same thing. Okay, and similarly this one. Okay, now apply this selection. So all becomes sum. Okay, so there are several statistics how you go through this. Okay, there are several statistics you can select from this. Okay, mean, median, etc., mode, etc. Okay, now you applied it and then okay. So what you are getting is, this is the in Andaman negotiation, the entire 640 data now it is reduced in the state level. Andaman Nicobar total number of household is 94,500. So what it does is, you know, it add up all the districts within that. Okay, Andhra Pradesh. So this is the total number of you know, households in Andhra Pradesh. This one, what you do is you can copy this and paste it in the Microsoft Excel and save it as an Excel data file. Okay, and then you remove the sum. So you don't want it, because this is a total. You don't need to you know, keep this particular thing. Okay, so this is the total population, total female population, that is right. Okay, now suppose I don't want to do this. I want straight away data should be created. SPSS data should be good. Now this is a table, in fact. Okay, this table you need to copy in any other software and then save it as a data file. But if I want, I can straight away create a data file by using this aggregate command. Okay, so aggregate is a kind of, you know, you can say that you know, summing up the data based on a particular you know variable, ID variable, but it goes into it makes a different database, different data .sh, just like this. It will make a different .sav files. So how you do this? You get aggregate and then the breaking variable. So you say that state is the breaking variable, and I want the all these. Now you can select all these data. Okay, teamwork. Okay, so we have data up to, let us say here. All these we have created, but this was the raw data. Okay, select all those variables, and then by default it gives the mean of the data. Then if you want the sum function, because here the ideal thing is sum function, because I want to see in Kerala, yeah, in Karnataka, what is the total number of, that means you have to add up the number of household in each district. So that means you need to use the sum function. Okay, you continue this, so it becomes a sum function, and then add aggregated variable to active data set. So this option should not be taken. You should take a new file, because then if you add it to the existing data, then the data becomes complex, right? So what you need to do is you have to altogether create a new data file containing only the aggregated variable. So that file name you can change if you want. Suppose if I want this file to be a state census 2000, state census 2000. So all this we are doing in a click. Okay, but in Excel you need to insert a row and then add it up, then copy paste. Also, maybe several hours it takes to aggregate. But here, click, you will altogether get a different file out of this micro level data. You get a macro data set. Okay, so you click save and then okay. So it created. Where is that created? This is not the creation. This is the earlier file. But if you want to see that data, you go open the data, because now it is an SPSS data file. So that file is here. Click on this. So it created a data set. Look at this. Okay. So here it is exactly the same variables, but the decimal places is shown as 2, which you can remove. So you have created a. If you don't want this underscore sum return everywhere, so if you don't want that, how will you manage that? You can go to edit, find, and I think you can no, that option is not there. So you can remove it. Okay. You can go and remove it. Now, even if you don't remove, doesn't matter. It will remain. Okay. So this way you can create an aggregate data. Okay. Within with few steps, you can create a aggregate state level data set, and then you can work on the same thing, percentages and etc. Right. I'm just going through the important things. Right. Identifying duplicates is not we will not use in this data. Then merging file, I can show you in another database. Okay, recording is done. So analyze. Now, suppose if we want to do, okay, I'll come back to the other data. Okay. So I'm closing this state level data. Okay. Now, how if I want to do a correlation between these variables? Now, correlation again, it is applicable for ratio scale variables, not for the categorical variables. Okay, if the categorical variables are there, just like I said earlier, you can do a chi-square test to see the association. But here, when you want to do a correlation, what you do is you go to analyze, you can use the bivariate correlation, and then select those variables, that ratio scale variable. Let us say I want to find out the sex rate, the correlation between the sex ratio, literacy rate, and percentage of other workers, you click OK, so you get a correlation matrix. Okay, so it says that the correlation is 0.126, but it is significant. Though the value in terms of the the magnitude of the value, you see that though this value is looking like small, but it says that it is highly significant value, which means that, what does it mean? It means that if there is a better sex ratio, then the chances of literacy going up is very high. Okay, so there is a high correlation between positive correlation between sex ratio and literacy rate. As the sex ratio increases, the literacy also increases. But as sex ratio increases, then the percentage of secondary and tertiary workers decreases. Okay, so which shows a male dominance in this category, right? Similarly, the literacy rate and percentage of this has to be very 0.59. This has to be very high, because the people who are working in the tertiary and other workers are supposed to have much skills and education. So therefore, if their literacy level is high, then this percentage of other workers also go up. So it is positive correlation. Okay, so this is how you can now interpretation of this. Sometimes what happens. How you see that, why this double star. Double star means it's highly significant. Okay, that means the level of significance is 1%. Okay, or you can say that the confidence level is 99%. Okay, or if it is 0.05 to 0.1, you may get only a single star. Okay, a single star means the value of this level becomes between 0.05 to 0.01, which means that from 0.01 to 0.05, the SPSS same level. Okay, so it is 0.05 level or 5%. Okay, and if it is between 0 to 0.01, SPSS give 2 stars, saying it is 1% level of significance. So 2 star mean highly significant. The other one you can say that significant, right? So this is how you can generate correlation, right? Now, moving on, we can do some more thing like regression. You need meaningful variable regression. Now, for regression analysis, linear regression, you'll have to keep the dependent variable. There will be one dependent variable and many independent variables, and you can select those. Now, here, because doing all these is very simple. You just have to click on the, suppose if you say what is the percentage of secondary and tertiary work, whether it depends upon the sex ratio, and you can bring it in here, and then you can click OK. So it gives you the results. Okay. So this way you can see what is the R square value is 38. So the 38.9% is the R square. That is the percentage of variance explained. Okay. So if this goes up, it means that the model is better. If this goes less, and then the model is weak, right? So now coming to another data set, let us see. I can complete it. Just you save this. Okay. This is about the small data. Okay. This is how you can do. You can work on small database. Now, if you have large data sets, you may not get the data in this form. Okay. So your data may be something different. I have shown one data. See, I have one ASI data with me. Now, this I think I have shown you. This data is in this format. Okay. So as such, right now we can't do anything with this data. So you need to convert this data into meaningful format, and then you have to analyze. Okay. So I don't know how many of you have experience in working with annual survey of industries data. Now, in order to analyze this data, you need a proper data structure. You need the schedule and tabulation plan. Okay. So if you have these things, then you can analyze. You can import this data and do some analysis. So what I will show, to show some commands like merging and all, I need to use this ASI data, because in ASI data the tables different tables are there for. Now you may think, what is block? See, if you go here, see, this is a block, this is another block. So A, B, so the blocks, the schedule is divided into many blocks. Okay. So the last block here is MN. Okay, so this is for office use only. So maybe the blocks, the last block which they provide the data is up to J, in fact. Okay, products and byproducts manufactured by the units. Okay. And for each of these blocks, you can generate data from a single text file, from this file. Okay, how we can see that, right? This you have to, I'm just closing this data, I'm opening a new data set. Okay. So this one, save. Okay. So now you have seen the schedule. Okay. Now you have the data structure here. Now data structure, in fact, when you purchase the data or when you obtain, now you don't have to purchase the data. All this unit level data is available in National Data Archive website, or it is available also in the ICSR website. Okay, ICSR data service. All unit level data is available in ICSR data service. That is different website. Not the ICSSR main website. You have to go to ICSSR data service. You can Google it, you'll get it. Or you go to the National Data Archive. So there you will get all NSSO, ASI, or any kind of national survey data. Now the basic method of getting the data or extracting the data from those unit level data is same. Only the data differs, but the methods are same. Okay. So therefore, if you learn it, then you will be able to handle any kind of data. So quickly, I'm going to it, how you can extract large information from using this structure. Okay. So data, I will open this data structure. Data structure is block A, B, C, D. Now, see what happened. It's only up to D. In fact, it's not only up to D. I only copied up to D. You see, if you go to the structure, this is a structure. So this structure goes A, B, C, D, goes up to J. Block E, F, G, H, I, J, I think. Okay. So this is the last page. So I showed you, this is the products and byproducts manufactured by the unit. Okay. But just for the, because we need to, from that PDF file, you need to bring it in Microsoft Excel to write syntaxes in, or the programs in SPSS. Okay. Now what I do, I'll show you how we can bring in those text file into SPSS. See, you can see these field names. So what we can do is we can keep the same name for the variable names. Okay. So first thing is in the syntax. So we can remove. Okay, no. Okay. The first line which I write in order to get the data in SPSS format is data list file. Okay, so data list file is a command which is used for getting the data from a flat sequential text file, right? So now you have to say data list. Now I have list, L-I-S-T. Don't make any spelling mistake. Okay, data list file is equal to, where is the data? You have to give the data. This is our data. Okay, right now you can't do anything with this data. In order to make it a meaningful data, you have to extract it. So we are doing the extraction part, right? So here you'll have to specify the path of this data. So the path of the data is this. So you say Control C. So this is controls. I use Control C and I pasted it over here. Okay, and then put a backward slash and then wait, and then where is the data? Okay, this is the data. So you can copy this name, or you can straight away write it right there also. .txt. So it's a text file. Okay. And you put quote sign, and then what you do is you put a forward slash. Now forward slash in SPSS syntax is a subcommand. It stands for subcommand, which means that data list file is not stopping there. Okay, is not, if it is if a stop completes, then as I said earlier, you have to put a full stop. Full stop is a command terminator, whereas if this command is continuing, then you have to put a forward slash and then give the contents. Okay, so the dictionary should always be put it in the forward slash. Now, what is how you create a dictionary here? First thing is in the dictionary, SPSS dictionary is the variable name. So it takes this format. Variable name should be there, and then immediately after that the byte positions. Okay, after that the byte positions, and then the labels. So these are the three things you require. So variable name you require, then byte positions you require, and then the label you require. Okay, so even if you don't put label, leave this label. Okay, label we can put later. Okay, byte positions. Now what is the byte positions? Now these byte positions from which character till which character the data is. Now if you go to the block A, in the block A, the total number of width is 2. Okay, now what will be the byte position? Byte start, byte end. Okay, or of this one. So definitely this will be from first till how many? So 2 characters starting from 1 to 2, and this one is from 3 to 4. This is how the byte position is defined. Okay, so if the total width is 2, which means that starting from the first till the second byte, it is the variable year. Now if there are, after that, if there is a character which says that 2 width, which means that the next byte position 3, and then till 4, it is 2, and then it is the next one is from 5. What is the next number till 10? So 5 to 10 it is 6. How you but I have written it manually. How you can get it using a formula? How you can get it using a formula? You can do like this, this one becomes this plus 1. What about this? This becomes this plus this. So this way. Is that correct? You got what I'm saying? What is byte position? Suppose byte position is something is continuously written. Okay. So if there are 2 width for the first variable, means that these 2 becomes the first variables. So how to find out the starting byte and ending byte is, first byte is 1 and the second byte is 2. So I have written from 1 to 2. The next to 2 characters, that is beginning from 3rd and ending at 4. Okay. So how you take is this one. Okay. So I have used the formula that this is equal to 2 plus 1. That means after this, whatever is there. Okay. And then this one is this plus this character. Okay. So this plus this. So that way you get the beginning and end. Now you can, you have to do this once only. Okay. Right. Now the last one is a filler. Filler means the 61 spaces is padded with blank. Okay. So you don't require it. So once you get the beginning and ending bytes, then you can write a syntax to get the data. So how you can do that, using again that concatenate command, you can use concatenate. You need to specify the variable name. Then a space is required. Then the starting byte. Now our starting byte is a variable, so I will click on this only. Then within quote you put a hyphen, and then you write the ending byte, and then you close it. Okay. So you get year 1 to 2. See, it has come in a single. You can see this. It has come in a single column. That is the variable name and the byte position. Okay. Now you drag this. The next one, BLK, because our second variable is BLK. BLK is starting from 3 to 4. So you just drag it and you will get like this. So your variable names and then your byte positions are here. Now you copy this and you paste it here. This is your dictionary. Okay. And then you put a full stop at the end of this. See, you must have noticed that, when I put the full stop, the data list red color changes to blue color. A blue color indicates that your data is correct, that your command is correct. You put a full stop. So you got that in blue color. Now you write execute, because here you are in a data transformation, means from a text file you are converting your data into SPSS format. Okay. Now what else you should know to extract the data. Not only this is just a dictionary only. Now, see here you see this is written here in the second one, block code always A. Okay, so how you have to tell, you have to, first of all, first you have to extract it, and then you have to say that select if set filter off. Another command for filtering is off. Set filter off. Select if your BLK equal to A, means because our data text file is only one file, but you have got different data files. Now how you can create that different data? Now if you are using a second layout, then it has to be B, because it is written in the block code always B. So if this is written, which means that you have to remove all other things, otherwise this data will be meaningless. So select if BLK equal to A, and then you have to say save out file. Save out file is equal to, you can put it in this, maybe in this folder. Okay, and change the name dot ASI12 A dot SAE. Or you can simply write, if you don't want to write this, block A dot SAE. This is the file I am creating. Okay, you put a full stop. In a similar way, the how you create other data is you just don't have to create another syntax for that. Okay, you copy this and then your data list file will be same, but you need to change this. This will you have to remove and put the second one here. Okay, and this has to be changed to B, and this will be changed to, because you will save it as a different file. Okay, now I am just bringing in that information, that is you have to this is okay, because this is the first one, this is second one, and then I will use this formula. Okay, now you copy this and then you copy this here. So this will be this thing automatically, because we use the reference formula B31, etc., right? Okay, so you copy this and put it in this place. And then you put that full stop. So this way you create the second one. Okay. And the rest, all the things are all right. Now, if you can save this syntax, let us syntax for data extraction. Now, let us See, so a lot of warning it has come. So in the second data, okay, let's see what has happened. Now you realize the problem. What is the problem? File, open data, block A. Is the data is correct? No, this data is not correct. Why? Because in the block it is written, it is always A, which means that it is, and also it is given the type. Without looking at this, we have just created. Now, if you don't specify, if you don't specify anything here, the SPSS assume that it is a numeric variable. So a small mistake we did is that, with this, now here the character is written. So the data type here is character, and this also is, the fourth one is also a character, okay? And the rest all are numeric. For the numeric one, it is fine, but for character, you have to write within bracket capital A. So that is why the error has. Okay, so here you write capital A to say that it is character variable. Okay, so this A stands for similarly here as well. Block. And now you have to go and see without looking at this. The character is only 2. So we have made only changes at these 2 places. Rest are fine. Okay. Now let us see what we are getting. So you save this, select it, and then run it. Yes. So we got, so these warnings and all you can ignore. It says that, somewhere it found, there is some space and all. So you can ignore. So this is a correct data. Okay. So you see that block B has come in the second data. Now, if you look at the first data, it is block A. So everywhere it must be A. So it's already open. Okay. Close this. No, this is wrong. Why? Because I have kept it open. That could be the reason. Or no, this one, the bracket is not closed. Okay. Now you see, again, select it and run. So that it is currently running. You can see towards the right side, lower right side, it is executing, running, execute, and then saving it. Okay. Now you see. So you got the data. So this is how you can get the large data sets, means which goes into thousands of records, So if you go here, you can see that right now you have only observation up to 52,775 in the block A, but in some other block, the data can be more than that. Okay. It goes into lakhs and all, but here the second data set, how many observations are there? So this also I think is block level data, so it goes into 50 only. Okay. If it is something about the production of some items for each, or the input used or the output, data, then there can be input. In the input file, there can be so many inputs used for production of some item. So the number of records goes into lakhs and millions. So this is how you can create your data. Okay, and now after creating the data, the next thing I said, how you can merge it. So the purpose of bringing this data is to show you how we can merge this data. So why you need to merge is, this data, the block B, gives you some information about type of organization, type of ownership, etc. Okay, of that particular industry. Okay, now number of months of operation. Does your unity have computerized AC system, etc.? So some variables are there. Some variables are given: number of working days, bonuses, what is the status of unit, bonus, provident fund, etc., etc. Okay. Now, suppose you want to do something, some cross tables from this as well as this, then the file has to be in the same. Both the information should be in the same file. Right now, you have different files. How you can combine these to form a single file? Okay. For that, each of the survey data, they have a common ID is there. Now, in our case, the common ID is the DSL. Okay, so DSL is a common ID. If you read the document, you will get to know what are the common ID using which you can merge your data, right? So DSL, wait. I will make a where is the block A1. So A1 is the DSL. What I'll do is rather than writing A1, I will change this variable to DSL because it should be the same variable name. So I change the variable name because this is a common ID. So I saved it, and then in this file also, then it is written, in block B, it is written DSL is AB01. So in AB01 also, I will change it to AB01, I will change it to DSL. Same. Okay. And now what I am going to do is I sort this data sort cases based on DSL. So whenever you want to merge two data sets, it is important that whatever is your primary key using which you are merging the data, you should sort data based on that particular variable. So you select here and you click OK, and now you save. So your block A is saved after sorting it based on DSL. Now you click on this data, you go to data sort, and then DSL, click OK, and save this data also. Right? And now come to block A. Now let us go to the data. There are two options here: merge file, add cases, add variable. So add cases is simply an appending. Appending means horizontally you are adding, but add variable means vertically. So what we need is, because variables should be merged, not the cases. Okay, so you click on add variables, and then this is block A. The currently open file is block A, and I want to add the data of block B. And what basis I want the data based on the DSL. Okay, this is the key variable. So the key variable you have to select here, and then if both the files are a unique file, you have to say both file provide cases. So once this option is done, you click OK, and you can see that, start, see, it's showing that SPSS is joining the, all that B data is also it. So earlier, our data was up to which one? Here, and that B02, etc. has also come here. So the data set has joined with this by equating that DSL. So it looked into the exact DSL code and then matched and then it merged. Okay. Now, why you are doing, as I said, that if you want to do some kind of cross tables, you can use it. Okay. Now, the analysis part again is very simple. You can do based on, you can do a frequency crosstab now, or you can analyze using, custom tables and all. Okay. So basically, now, one thing you have to remember, whenever you do analysis using survey data, you should look for any multiplier present. Now, here you can see there is a multiplier. Okay. Here, although you see 111, somewhere it will be 1.0, 1.01, 1.2, or something like that. You can see. Now, if you see a frequency of this, you'll understand. Okay. Multiplier. You can see, there are ones are there, twos are there. So there are so many values are there. Okay. So that one which is showing 6, it is not exactly 6, it is 6, maybe 6.01, 6.0. So those are different values. That is why it is repeating. Okay. That you will get to know only if you put some decimal places into this. Okay. So although here it shows frequencies multiplier, you can see 1.25, 1.50, 1.67. So there are several different values there. Now, what it means that, if there is, suppose there is 2, multiplier 2 is there, it means that one row is equivalent to 2 units, which means that whenever you estimate something, you should always use multiplier. Okay. Now, if my aim is to find out how many units are there, how many, this is the A11 is what? What is A11? A11 is number of units. Okay. Or what is the status of unit? Let us say number of units. Okay. You should first weight the cases by using a weight. So weight cases by what? Multiplier. So you can see your lower right side, you can see that weight is on. And now you calculate. So putting a weight is important if it is a survey data. Okay. So frequencies of the A11, you can see, there are a number of units, 1, 2, 3, 4, etc. So this is the frequency of that, right? Now, estimation, in fact, when you estimate, you should always go to the estimation procedure. Now, factory in operation. So what does A11 means? Factory in operation. So what it gives you is the total number of factories in operation. Okay. Sorry, total number of factories. Factories in operation is A11 for A12 equal to 1. Okay. So which means that if you want to find out factories in operation, then you have to find out, tabulate A11 for A12 equal to 1. Okay. Now there are ways of finding out the fixed capital. That is, you have to find out the summation of code. That things are there, but because of the lack of time, I'm not going. If I enter into this, it will take another more than an hour. So I'm not going into that. So basically, if you go through this tabulation plan, you can calculate any value, fixed capital, physical working capital, all these can be calculated using this tabulation plan. Okay. So if you have any question, please ask me. So once you merge the data, again you get an untitled one. So you have to save it as it is the merge of block A and B. You can put block A, B, so that you will understand that it is a merged version. Okay, so you get a block A, B data, right? So
good afternoon, sir.
yeah.
So if you don't mind, once again, could you explain correlation for process from the census data?
From census data. Okay, so you open this data. So what I mean is, correlation is meaningful when you have indicator type data, okay, or variable, okay, not okay. For this also you can find out, for this also, but you cannot find out correlation of categorical variables like this. Okay, that is one thing I said. Now how to obtain it? You have to, now suppose if there is 3 variables, you will get a 3 by 3 matrix. Okay, so you go to analyze, you click on correlate, you click on this bivariate option, and then select those variables. Okay, and then after selecting this, you click OK, so you get the correlation. So you'll get a 3 by 3 matrix, right? Now, calculating correlation, you can see correlation, but there is another thing, which I think will be useful to you. I think you have any question in the correlation? This is how you can find out the correlation. You want to see how you interpret it? By looking at the significance level, you can see whether the value is, or by looking at this sign also, you can make out, whether this value is statistically significant or not.
That only my question, sir. How to interpret it? The table, okay. How to interpret what is the meaning of values? No,
looking at the values, I said that, if the two-tailed significance level, if it is, it's very close to 0, okay, or if it is between 0.01 and 0, definitely this value will be double stars. Now a double star indicates that the correlation is highly significant. What does it mean? It is highly correlated. Means these, the 0.59 double star means the percentage of other workers, and the relation between literacy rate and percentage of other workers is highly significant. It is highly correlated. Okay, and it is statistically significant.
Thank you.
But using this correlation, you can also create a, what we call is principal component. You can reduce the dimension of this data. See how you can do dimension reduction. You go to the factor analysis, using which you can create a PCA also. How you select these variables and put it here. Sorry, string variables are not allowed in the list. Where is string variables? is it string? It is not string. Okay, so if you score, if you save the score as a variable, what it will give you a principal component also, which is we can interpret it in the same way which I said for the Z scores. You know, you get a factor score for this. So this factor score you can, so wherever the factor score is high, it means that you know, based on these three variables, the district is you know, better developed. Or if you go further down, you can see that, you know, it will be negative values down here. So this is also a way. Now what exactly it does is, you know, the standardized value, it get multiplied with the eigenvector created from the correlation matrix. The 3x3 matrix, you know, eigenvector is generated. Eigenvector is nothing but it is the characteristic roots, you know. So that get multiplied. With the Z scores, so that now this represents a weighted index, whereas the other one which we created is just a composite index, but this is called a weighted index. Okay. So I think the time is up. So if you have any question, you can ask me, or else we can stop.
Hello.
Yes.
Hello. Good evening, sir. I am Satvik, a research scholar from management discipline. I have one query relating to this normality test. Which test can I use to check the normality of financial data?
Normality test, I think it is there in here itself. You can use simply, you can use within the, sorry. You give the data here, and then you can use this, you know, histogram with normal curve on histogram. By looking, by ticking on this, select the variable and continue, you'll get whether the distribution is normal or not. Okay.
Okay, sir. Thank you.
And any other question? Anybody has any other question?
Excuse me, sir. Okay, present we are unable to ask any questions, but could you drop your email ID in the chat box, sir? We can contact in further if we get it. Because in one day class, it is not possible to learn this subject.
So I will give, you can take it from Dr. Rajesh.
Okay, sir, sure.
Okay. So is Dr. Rajesh is around?
Yeah, I'm around. So
shall I close this session?
Sir, I have a question, sir. Varghese, sir, please, if you can, just a question. Sir, would you please mind helping me with, I know this is a critical question, but would you please mind helping me in knowing how do we analyze when we do factor analysis on the basis of eigenvalues? I know that I know that more than eigenvalue one, if we take it in terms of
yes.
So if we have a table, how do we make sure that these sub items would get into that factor? I mean, I have a table
Yeah,
and that is very confusing.
I got your question. You know what? It is based on the the factor loading. You know the eigenvectors. It will create. Suppose if there are two components are generated, there will be two eigenvectors also.
Yes, sir.
So in that first eigenvector, you know the variables, higher loading, whatever is the variable. So for example, 0.7. Looking at the value, one variable should not equally load in two components. Then it will be something wrong. Okay. So if a particular variables, weightage is higher in one variable and lower in another, higher in one component, lower in another component. Then in whichever is that higher, which means that suppose you have 5 variable x1, x2, x3, x. Okay.
Yes, sir.
Now and two components. Let us say component 1 and component 2. Now in component 1, which are the variables which made the higher weightage? That is what your question.
Yes, sir, yes.
Now, if x1 has the higher weightage, definitely the first component x1's that coefficient value will be higher. And suppose x2 is loaded higher in the second component, in the second component, x2's value will be higher.
All right.
If it is equal 0.5, 0.5 in both, which means that that particular variable is not fit for including in your analysis. So that should not happen.
That should not be included in any of the factors.
If it happens, then you have to do some kind of other way of doing, like you can maximize the way, you can do an orthogonal rotation. You have to learn that principal component, means you have to do a Varimax rotation, rotated factor. Then you can adjust it.
All right.
So that you have to read a little bit.
So it's very difficult to understand the values, communalities and all. I have done this treatment with one of the question which is there in my questionnaire for my postdoctoral study. And I tell you, I'm trying to measure the perception of farmers related to the agricultural markets in their areas. So, because of the constraint that the respondent was a farmer, I could not take a scale beyond 5. I mean, it was a Likert scale of 5, strongly agree to, because it was anyways very difficult for me to make them understand the difference between 1, 2, or let's say 4 and 5. I mean, 3 anyways is not, so in that sense, Varghese sir, I was very, very confused. So how do I do? I got 5 components. I got 5 factors. But then in terms of the loading values that I'm able to interpret, I was not able to make any sense out of it. That's why I asked you.
These communalities, what is is in fact the correlation between the component and the individual variable.
Individual variable, right?
So if that has got a higher value, which means that's an important variable.
Okay. In case of further query, I'll mail you, sir. I'll mail it. Thank you so much. Yeah, thank you.
In case any further questions are not there, we can close this session. I have given everyone the email ID of Mr. Varghese. You can contact him and raise your questions and have some clarification. So I thank Mr. Varghese for his very elaborate lecture on SPSS and how to manage the data and how to organize it properly and extract it from unit level data. So it's very informative, and I think most of them have benefited from your very detailed lecture. Thank you, sir. Thank you very much.
Thank you. Thank you. Thank you. Thank you.
Thank you, sir.
Elect. Okay. Okay, so how was the lectures today? Fine, no?